Hello friends, welcome back to the JCA Ecosystems channel. We're going to go with what is promised to make a homemade generator. We are going to do it with all the elements that are easy to get so that you don't even have to use a lathe. We're going to do it with 2 brake discs. These are brake discs of a car, and we are going to incorporate them in such a way that we are going to be able to make a generator. This is a disc. The other disc is this one here, and I am going to explain how the center says the mass of these. This is a front mass of a Fiat car, and I put it inside a rear mass. These and these are the same. You have to get a front mass and a rear mass. This is a rear mass, inserted one inside the other, that exactly matches the size of the bearing. Everything does not have to be turned, only this piece remains. What did I do with this piece? The screw here, with a spacer to give it the height, and the 2 discs will be parallel. For example, I put 10 magnets on these discs. North, south, north, south, north, south, north, south. There are 10 magnets distributed symmetrically, one in front of the other, and we put it in place. See what happens. Well, here we are. There it is. The 2 discs remain. I'm going to pick them up so you can see them. And what are we going to do? We are going to put coils on it. This group of coils that you are seeing here. These coils are going to be inserted at the end between, like a sandwich, between the 2 discs, with the right measures so that they do not rub. We are going to make the coil on the lathe, and I'm going to explain how the coils are made and how they are connected. And we are going to assemble it completely. We are going to make the generator work on the lathe, and we're going to see how it generates and how many revolutions. We should go to the lathe now to show you how I build the coils, which is very important, because knowing how to build the coils, we are going to screw them on the discs, on the brake discs, divide them by 10. Then there are 10 places, 10 holes exactly symmetrical, and we are going to screw it like this here. Well, we are going to go to the lathe, because the lathe can be done by hand as well, but we are going to do it. I have a small screw in the lathe, and we are going to wrap the wire. Let's go to the lathe. Well friends, now we are on the lathe. I use the lathe because it is a simpler matter for my case to wrap the wire. I made a matrix that is a screw with a cap, which I'm going to put right there. Now the coil has a core. The coil that I have made has a core. The core is a sheet. The more oxidized, the better, because it does not have to make contact with each other. The first thing I do is thread the core onto the screw. I am going to tighten it. So it doesn't slip. As I said, I am making the inner core of the coil, which is metallic. It has to be a rusty iron blade so that it does not make contact with each other to avoid parasitic currents or eddy currents. There they are turning, and once I screw it up, I put adhesive tape on it. This is paper tape because it withstands the temperature better. And I'm going to take it out. Once I have wounded the core, which is a sheet metal, I am going to take it out. Here I am going to show you one that I had done before. You have to make 10 cores of this, just like this. It's exactly the same as that one, cap, which is this one, that I tighten it in this place. Look at the space that remains. I am going to look for the wire. This is the wire. In this case, I have a little left, but so that you can see how it works, you have to give 180 turns to each reel. I am giving you all the details, so no matter who does it, it comes out right away and they have no problem doing it if they watch the whole video. There, they will realize that it is done with great detail. The wire is 0.95. It can be thicker or thinner, not much of a difference, but I have been doing it with 0.95. Now I'm going to wind it. I don't know if the machine looks well here in the center. It's like a spool. I'm winding it there. It's 180 laps. I have a little mark here and I realize when it is reaching 180 laps. You have to make 10 coils, just like this one. When I finish it, I am going to connect it, and we are going to have it tested so that they can see how the device works. Well, I join the two ends so that it doesn't unravel. And I put tape on it again. I do it with paper tape. Tape, masking tape. Why? Because it withstands high temperatures. Well, now I take it out. You can do it by hand. I show you how I did it. Look how the coil is. In this case, it is a little smaller because it did not have more wire, but the system is exactly the same. This is the core. This is the core. The core is made of sheet metal. It is made of laminated sheet metal, but instead of cutting the sheet metal, what we have done is twist the sheet metal like a spiral, and notice that it remains like a little hole because the veneer is from the smallest to largest. It's done. So here is a conical well where the screw will be embedded. It's done on purpose. Actually, a little thicker the coil. I ran out of wire because I already consumed all of it when I was making the generator. Well, now we're going to go to work and we're going to assemble the generator with the coils. After I put it together, I'm going to come back here to the lathe and we're going to make it work to produce electricity. Let's go to the bank. Well, now we are at the bank. The coils, come on, there are 10 coils. We are going to put 5 in series. Here I have the 5 connected in series, the input of one with the output of the other, the input of one with the output of the other, and we are going to put them in a stator. Why the stator? Because it is one that is static. Rotor, the one that turns. We take a screw, a small plate of this one that is a washer, and we're going to start putting them here. 1, 2, 3, the 4th reel, and this is the 5th that I hadn't put it on. The connections are this. The video is going to be a little long, but you have the possibility that if you see it in its entirety, and do it exactly the same as I have done, I will guarantee the operation, which is very important, because many times you do something on the internet and it doesn't work. I'm going to put the nuts here below the screws. I'm going to put the nuts on each screw. I try to make it light because I don't like to delay in things that are not relevant, because people get bored and they don't like it, and they don't. And only the colleagues do it to kill time. And I'm interested in having an ending because we could do it in 2 videos, but I will do it in 1. If later we have to do more rehearsals, we can make another video for the rehearsals. Already 5 coil groups. I have to tighten them, and the screw goes inwards. It has to have the distance. It has to be embedded and not have a line there. Because if it's not going to rub against it, oh no, this washer is thick, it has to be locked. The screw must be tightened until the washer is embedded. There it bends. Now we tighten this one, not too much either, so it doesn't short circuit. If you want below, you can put another insulator, a cardboard, a fiber. I have to put the coil tight until it is at the level where the screw is not too high here, because otherwise we're going to have problems with the magnets. Now I am tightening the fifth coil of the first group. I am going to do 5 coils in series and then 5 coils in parallel. It's going to be a series parallel system. You can put them all in series, but the voltage is going to be a bit high. This increases the amperage. Then, if you want, you can try. They put series in parallel. 1, 2, 3, 5. Now we're going to put the other group of coils. I already have them done, but you already realize how it is. You have to put it in the correct position. If you turn it around, it will not work because the polarity will be reversed. But if that happens to you, all that you have to do is change the polarity of the cable of that coil, which is misplaced. I'm going to have 2 groups, 5 coils here and 5 coils here. These 5 coils are in series and these 5 are in series, but in turn separate. I'm going to show you the circuit on paper. As I told you, I'm trying to make it as detailed as possible, because if you want to do it with 2 brake discs, you don't have to look for or do anything. Simply make a support here that it is higher, because the height you need is the height of the magnets of the coils. If you make it very low, it will rub, and if it's very high, it will generate little energy. This system works quite well. The only thing that is separate is the magnets. It could be put in 10, 20 magnets and more coils, or the coils that you want. If you put more coils, of course, you have to decrease the number of turns each coil has, because the sum total is what matters here. There, I am tightening it. I tighten the other reel and I repeat it again. I am delaying it, but it is because I want you to see all the details in case you want to repeat it. The other way, you are always left with some doubt. These, if they do it exactly the same way as I am doing it, it will work for them, which is very important for those who want to do it. In the other case, I made a generator with a motor, but not everyone has that generator, that motor. So I had promised that whoever wanted to make it at home, I was going to show them how to do it. Well, here we have one missing. This one is missing. We are going to try not to leave any high. This one seems to be a bit high, and we are going to see that this one is also high, but it is loose now. I tighten it, and it will go down when I put the disc on it. With the magnets on top, I will find out if it is high or not high enough. Now, I am going to have 4 points, one by one, group and beginning end of one group and beginning and end of the other group. This is one group, and this is the other group. And now I am going to show you the connection. In this row, here are the 5 coils. 1, 2, 3, 4, 5. The entrance, the exit of one, which is the entrance of the other. The exit of one with the entrance of the other. The exit of one with the entrance of the other. The exit of one with the entrance of the other, that will form north-south, 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 5 coils. The other section is exactly the same. The exit of one with the entrance of the other, the exit of one with the entrance of the other, exactly the same, and I will have south, north, south, and so on. The only difference is that I'm going to put them in parallel. I am going to put the output of this with the input of this group, and the output of this group with the input of this group. In short, it is 2 coils in parallel. In other words, there are 5 coils in series. 5 coils in series, but then I transform them into parallel. If you guys want to make sure this is okay, what you have to do is put a battery in to be able to determine if it's okay. We are going to use a magnet and a battery. We are going to connect the battery to the first group of coils. Do you see? There it is connected. Here it is rejected. Here it is attracted. This one is rejected. It is attracted. There is one misplaced. For example, here it is attracted. Here it is rejected. Here it is attracted. Here it is rejected. And here it is rejected. This one is backwards. I'm going to have to invert it. That is a very good test, because sometimes one is wrong. Since this one has a black ribbon, I didn't realize it and put it on the backwards. One that is backwards does not work properly. I'm going to take it out backwards. It means this. Look, we turn it like this, and the problem is over. You can change the connections, but since it is connected, the only thing that changes is the position of the coil or the electromagnet that it is a coil. I'm going to measure it again, and there has to be a rejection and attraction. A rejection attracts. It is sequential. Let's try again. We put power back here, and we will try again. This is attracted. This one attracts, and this one attracts the two. I don't know what happens. A lot of power as well. This one is rejected. This one is attracted. Now it's okay. This one attracts. This one repels. That one attracts you. That one repels. That one attracts. Now we try the other group. It has to do exactly the same if it is well connected. We connect there, and this is the current of the other group. It is rejected. It is rejected. It is attracted. It is attracted. It is attracted. It is rejected. It is attracted. Here's the bad one. This one is attracted. It is rejected. This has to be attracted, and it is being rejected. This one is also backwards. It's difficult because you don't realize it. You can make a mistake, but it's good that it happened to me because that's how you see it. The possibility that if that's not right, it can be reversed. I am giving you the solution that if it gets wrong, you can correct it. I take out a coil, I put it on the other side. We are going to check it again because a coil that is not good is not going to generate current, or it will generate very little with poor performance, because this is like a battery. Each of the coils produce a certain voltage. If it is good, the other way around, it eats current to the others. If it is set as it should be, each one adds it to the other. We are going to produce current again and check it. The magnet, there it is. There it is with current. It is rejected, it is attracted, it is rejected, it is attracted, it is rejected. Perfect. Ready? We can now say that it is connected. Well, now we would have to put the disc that has the magnet that is called a rotor because it is the one that rotates. This is this actor because it is one that is ghetto. It has some terrible neodymium magnets which grab everything I find. I put it like this, that I didn't bend my fingers, and that I put it there, and that there is enough left for it. The same mass has some little screws that come from 10 to put it here. See? And the generator would already be armed. We are going to test it on the lathe, and surely if everything goes well, it will generate. If it is wrong, it will not generate. I have to see if there are some that are very fair. We could say, yes, this one is very fair. I tighten it more, this cover. I'm going to tighten it more. Let's see if it's in another one that slowed down. This one is half slowed down because the little plate has gone forward. I'm doing everything inside here, so make some mistakes. This one is very high. I have to lower it. Anyway, this one is a bit high because in reality it has to be made a little lower so that this theme is not so dramatic. Well, I tightened the screws well. I put one with the beginning of the other and the end of one with the beginning of the other. That is, they are parallel as they were in the drawing that I made for them. We are going to take it to the lathe. Let's go to the lathe. Well, we are going to take it to the lathe. I'm going to tighten the lathe. And this is the stator. I'm going to stop it with the car. I'm going to leave the connections on my side. Here they are. I'm going to install a light bulb. We're going to put a car light bulb. And here we see the power. 60 watts. Let's see. There it is. 60 watts on high and 55 the filament low. First one filament and then the two together. In other words, they're going to see 115 watts. 115 watts in total when it's working. Well, let's get to the way. If I lock the rotor, I'm going to lock it with the car. It's going to be problematic because I haven't prepared anything for it. But I'm going to connect the two cables, one at each end of the generator, and I'm going to put it on the lathe at the slowest speed. And it's already working. Look there. They're not given even 100 revolutions at the minimum speed of the lathe. I'm going to put it at 150 turns. It does this because there is a lot of distance between one magnet and the other. If you want to make a generator with 20 magnets and put the coils together, and because I have quite a bad grip here, it is not directly gripped. And now I'm going to put it at 150 turns. And there we stop. There it is, 150 laps. Look how beautiful this is going to generate. That touch, great. Now we're going to put the two strands together. There it is, with both of them. There it is at 115 watts, the two filaments together. That noise is because it is heating on the car. There it is, 150 laps. Just imagine how extraordinary the generator is. Of course, if we put more magnets to make the drag lighter and even lower revolutions. I'm going to increase the revolutions. I'm going to put it at 300 laps, 360 laps, but it is very likely that the light will burn out. I don't know if we're going to be able to do it. There are the two filaments. If I leave one, it will turn even wider. Oh, there it is, 360 turns. What happens is that it is likely that we will burn out the bulb. Look at that noise. It is because the stator is moving from the lathe. There it is. See? 360 turns. And at 150 turns it is optimal. The two filaments are working. Well, friends, if you want to do more tests, we can do that later. I have already shown you how to assemble the generator, how many turns there are, how it is connected, using two vehicle brake discs that are not anywhere. There is a problem in getting them. You can have a generator. Until next time, and the promise kept. I told them I was going to make him a homemade generator. See you next time.